everyone. Welcome back to the second part of the physical world, and today we're going to look at the climate of the Earth and what causes changes in climate, or just the different climates that we see around the world. And again, like I said yesterday, or in the last video, that a lot of people confuse weather and climate. And I say that because a lot of people on the news talk about climate change. And really what they're talking about is weather, normal weather that may be different, is not necessarily climate change. Climate is weather conditions at a particular location over a long period of time. Northern Russia, here is the example I give, has a cold climate. It is cold all the time. Weather is the condition of the atmosphere at a particular location and time. And I get it, it's confusing. We're just going to do the best we can with it. But weather is the complex result of several conditions. Water vapor determines whether there's going to be precipitation. Have you got cloud cover? Landforms and bodies of water. Landforms block certain things. A lot of times, if you think about the snow that we get in York, in South Carolina, it comes from Atlanta. It doesn't come from the west because the Appalachians tend to block it. That is not to say it never happens. It is to say it's rare. Our snow tends to come from the south. But you've got elevation, and we're going to talk about these, but you also have air movement, and that's what we're getting ready to look at in a second, is all of those, or at least a lot of those. We do have some weather extremes, hurricanes, typhoons in Asia, tornadoes, blizzards, droughts, and floods. And I would say, probably with the exception of blizzards, that we get hit with all of them at some point in time. And though where we are, you might not think about us getting hurricanes, and we have been out of school for winds in the past. The winds are up because of hurricanes coming in, and we get weather from hurricanes. We get some of the rain and the wind from the hurricanes, and in some cases the floods. A few years ago, South Carolina had some massive flooding due to Florence, Hurricane Florence, very slow moving and very large hurricane. But in 1989, we actually got hit with a hurricane, Hurricane Hugo. By the time it came inland, it was still a hurricane when it got to York County. So we have actually, our area has actually been hit by a hurricane, and tornadoes and things like that. But we do have some weather extremes in our area. So factors that affect climate. One is wind currents, and you can see up here at the top, and I'm going to make this bigger in a minute, these wind currents. And I'm going to look at each one of these specifically in a minute. You have ocean currents, and you got this right here, and you can just see the way they move. And this is the way wind moves across the earth, and the way that our ocean currents move. And these affect, by the way, our weather. But this is a long-term thing, so that's why it affects our climate. The zones of latitude, our elevation, and this is getting into mountains or down low, below sea level. The topography, and this is the landforms. You can see the mountains. You can see these are low mountains, and these are very high, rugged mountains. Okay, all of these things affect climate. So your wind and ocean currents help distribute the sun's heat from one part of the world to another through convection. And I need you to know what convection is. Okay, this is one of your terms. Convection is the transfer of heat in the atmosphere by upward motion of the air. Okay, so it's moving of air. And if you want to think about a convection oven, that's exactly how it works. It moves the air upward, and it's kind of going through, and it cooks through. It cooks from underneath also. It doesn't just beat heat down on top, but it brings it up and underneath, and it cooks fuller. A lot of times convection heat helps to cook quicker. Wind occurs because sunlight heats the Earth's atmosphere unevenly. The warm temperatures cause air to rise, and that creates low pressure. Cool temperatures cause air to sink, and it creates high pressure. Just think about rising and going low like a seesaw. As the air rises, the pressure goes down. And with cool, as the air sinks, the pressure goes up. And then to think about warm air rises and cool air sinks, okay? But think of it as a seesaw, all right? Air moves along the pressure gradient from areas of high pressure to low pressure, and cool air moves in to replace the warm air. This seems very confusing, and I'm probably not going to ask you a specific question about that. I just want you to see that this is what happens. This is what creates the wind. And that wind is important because it's going to distribute the sun's energy. Here are those wind currents that we looked at on that earlier slide. You have your prevailing winds. Okay, this is wind in a region that blows in a fairly constant directional pattern. And this is based on those latitudes, really. If you go back to that, we'll see latitudes in a minute. But look at this. In your polar areas, it's going down. It's blowing from the east to the west. Okay, and you go down an area, you go down a latitude, and these are your westerly winds. They're blowing from the west to the east. Okay, your northeast trade winds. And then you're going to do the same thing below the equator. This is your equator right here. Okay, so your wind at the equator is blowing east. Okay, you got your westerlies and your subtropics, and then you've got your polar blowing also to the east. I'm trying to say this. I'm trying not to be confusing, but if you really sit there and look at the diagram, you can see that. Okay. The Coriolis effect is the resulting deflection of the prevailing winds caused by the Earth's rotation. And by that I mean, look at the way it turns. Can you see how it blows down? If the Earth weren't rotating, then it would just be a straight direction. But because it's rotating, it's being deflected to the right, if this makes any sense whatsoever. And then you have this area right here called the doldrums. And this is a fairly windless corridor. Okay, there's no real wind there. And if you get stuck there in a sailboat, oops. Okay. Your ocean currents are, well, they're described as rivers flowing in the ocean. And if you look at this, I'm going to make this big because I love this picture, because it has the red is your warm current and your blue is the cold current. And I'll come back to this in a second, because this is where some of your questions this is where the answers for some of your questions are. But you'll notice that water moves in circular movements. They're circular systems. Warm water flows away from the equator, which doesn't that make sense, and toward the poles, and it's going to heat the water as it goes. And when it gets toward the poles, it's going to cool, because all that cold air, all that cold water is coming in, so it's going to cool it up, and then it's going to pull it back up toward the equator. Okay, so it's just kind of like we talked about with the water cycle. It's just a cycle. The winds blowing over these ocean currents are going to affect the climates that the winds cross, if that makes sense. If it's blowing warm water, it's going to be warm air. If it's blowing cold water, it's going to be cold air. Okay, but let's look at this. Let me see if I can, because specifically I'm going to ask you a question about the Peru current. And you can see, because it's off of Peru, that's why it's called the Peru current. But it's coming up. You see your Southern Ocean there. It's coming up from the southern pole, and it's going up. So you're probably going to have some pretty cool weather here. Makes sense. And as it gets close to the equator, it's going to begin to warm. okay? And some of that's going to come back into the South Pacific and go back up, but others going to come out, it's going to warm up and it's going to hit into this equator current. So it's interesting the way it works out that way. I think that's great. But those currents affect the temperature of an area, okay? It also affects the precipitation of an area, okay? Warm winds, you tend to see a little bit more precipitation. And this is an example of climate changes. Now, this is not necessarily about man-made climate change, but things that change it. You have a periodic reversal of the pattern of ocean currents and water temperatures in the mid-Pacific region, and that's called an El Nino. Presently, we are in a La Nina, which it has the opposite effect, okay? Zones of latitude also affect climate. And again, you can see your tilt, okay? And remember we talked about the winds a second ago. These are those areas, polar, westerlies, easterlies, westerlies, and we can't see the polars down there. But your low latitude zone is the area between 30, here's the equator by the way, is between 30 degrees north and 30 degrees south. I should say south, I'm sorry. And it includes the tropics of Capricorn, the Tropic of Capricorn, the equator, and the Tropic of Cancer. Okay, and some of these regions receive direct rays from the sun year-round, mostly at the equator, and they have a very warm to hot climate. And this actually makes sense if you think about it. Look at this right here. We're just above it. Our region is just above it. But think about Florida, think about Louisiana and parts of Texas and Mexico and California, and how great, and when I say great, I should say warm weather they have. It seems like year-round. They have very, very mild temperatures. But when you get to the equator, they have warm temperatures year-round. It's always warm for the most part there, unless you've got elevation issues, but that's another story. But it's a very warm to hot climate. And it's not to say that they don't get cool temperatures. It's not to say that they don't actually have freezing weather every great once in a while, but it is rare. But that's a low latitude zone. A high latitude zone is your polar area. It's from 60 degrees north to 90 degrees north, or 60 degrees south to 90 degrees south. And when the Earth is tilted toward the sun, whatever hemisphere is toward the sun receives continuous but indirect sunlight. So if this area is toward the sun, then you've got your Alaska area up there getting almost a full day of sun. And Alaska's a little bit below it, parts of it, so it's not going to get the 24-hour day sunlight. Your mid-latitude zone is where most of the United States falls, okay? 30 degrees north to 60 degrees north in the northern hemisphere, and then in the south it's 30 to 60 degrees there. And this is the most variable climate on Earth. It's temperate. You've got fairly hot to fairly cold with dramatic seasonal weather changes. And you can imagine this. You've got Boston or Maine in the northeast United States, which would have fairly cold winters, a lot of snow. Then you've got York, South Carolina, that has a fairly mild winter. We might have a snow or two. We might have some frosts, or we might have a very mild winter in which we don't see much variation at all. You can also go out west. You can, up in these latitudes, up in these areas right here, very, very cold weather up in the Dakotas. So we have a big variable here, but it's temperate for the most part. You know, you can, and we get hot in the summer, and they do too. They get very hot in the summer also, but it's usually those cool temperatures when you begin to see that variation. Elevation is an influence of climate because different temperatures. Y'all know that if you go up into the mountains, it tends to be cooler. That is not to say that they don't get warm or hot in the summer, but tends to be cooler. they do tend to be cooler. And our mountains here, the Appalachians, tend to be a smaller range. But if you go out to the Rockies, even in the summer, you can have fairly cool days. But as elevation increases, then temperature decreases. And you can go, like, again, look at your elevations over here. So you can see your highest peaks are these browns. Okay, so if you head out, all right, over here, you can go to the Himalayas and Alps over in here. These are fairly high. Some of these are going to have snow tops year-round, particularly out in here. Mount Everest so is one that I'm thinking of particularly. But yeah, so as you go up, the higher up you go, the cooler it gets. Topography is just landforms, and they affect climate, especially your mountain areas. You've got winds that have a lot of moisture in it, cool as they move up the side of the mountain, and they release rain or snow. But by the time those winds reach the other side of the mountain, they're dry, and they become warmer as they flow down the mountain. So that mountain serves as, in a way, it serves as a break. Now listen, you've got all of these types of climates, okay? But the truth is that they're divided into 5 large regions: tropical, dry, mid-latitude, high latitude, and highland. Now you see here with tropical, you've got tropical, wet, and dry. So it depends on where you're going to go. But you can see all of the different ones you have here. You have semi-arid, desert, and you can kind of come down here and you can break it down. Let me see if I can bring it over here. In the United States, you can see how varied it is. Where we are is this light green, and that's C, so we're mid-temperate. And then F is fully humid. No problem believing that. And also A, hot summer. That's us, isn't it? Sounds about right. Then you can look in the Appalachians, and they're slightly different. More of this CFB, which is warm summer, not hot summer, but warm summer. So, but you can kind of look at this map. This is the Köppen climate classification, which I think this is an interesting look. You can see the different parts of the United States. Climate change, does it exist? Is it man-made? Whatever. Climate changes. It does. We have had ice ages in the past that some say we're presently coming out of one now. Is it man-made? Well, I don't know. I will say again that we have had climate changes in the past that were not man-made. So this is a controversy today. The idea of man-made climate change is controversial. Does it mean that climate doesn't change? No, climate changes. Climate does change over time. But the air temperatures have increased since the 1800s. They've increased by 1 degree. Some estimates for the next century suggest that an increase will be almost 3 to 5 degrees. Now, that may not sound like a big deal, but if you're looking at overall temperature increases, that's a pretty significant increase. 3 to 5 degrees is. 1, I don't think it's so much. But again, I think the argument made for man-made climate change, because the 1800s, one, we are recording temperatures now, but also we have seen industrialization, and I think that a lot of people are concerned over that. Some believe that this warming is natural, because again, like I said, we go through these warming and cooling cycles. 18,000 to 20,000 years ago, we were in the last of several ice ages. And like I said, some argue that we're coming out of the latest one. I'm not really sure about that either. But Others say that this is caused by the greenhouse effect. You got a layer of gases released by the burning of coal and petroleum, and it's going to trap a lot of solar energy. It's going to cause higher temperatures, just the same way we would see a greenhouse working to trap in the solar energy to help raise plants in the winter. Um, and again, it's industrialization, that lead people to believe that the amount of greenhouse gases has increased over the last century. I will leave that to you. I am not going to get into a big climate change discussion over that. Soil and vegetation, and we're almost done here. Soil is a thin layer of weathered rock and humus. And that's organic material in soil, also made with air and water. So the world's food supply depends on the top 6 inches of soil. Point blank, stop. That's it. And there's several factors involved here: depth, texture, humus content of the soil. That's going to determine the type of vegetation that can be supported in a region. And this is going to actually influence people. What can we do there? And we can look at U.S. history to determine that. In the Northeast, it was rocky, it was cold. You had a short growing season, and so they're kind of reduced to subsistence farming. Whereas in the South, you had a long growing season, you had a great climate for it, you had great soil for it, and they began to grow cash crops, and they became very wealthy with that. So the kind of soil you have, along with the kind of climate you have, influences our activities. Okay. Now you have vegetation regions, and natural regions provide the stage for human activities like farming, livestock, and timber. Soil temperature and moisture influence the type of vegetation that thrive in a particular region, and they're identified on the basis of the ecosystem. And an ecosystem is an interdependent community of plants and animals, and the ecosystem of a region is referred to as a biome. Again, those are just basic terms. Okay, so your vegetation regions here, you've got your forest. And again, if you look at us right here, it says here that we are deciduous and mixed forest. If you look at our region, and just below us is coniferous. But you can tell that it's forest is categorized by the types of trees that we support. You've got broadleaf forest, but you also have needleleaf. Broadleaf is maple, oak, birch, cottonwood, and these are your deciduous trees. You see this in the northern hemisphere almost predominantly. And if you look at that, go back down to that green, you'll notice that there is very little of this green in the southern hemisphere. You have little bitty places of it, Australia, a little bit in Africa, and just a little bit also in South America. But for the most part, you see it, and more over in Asia and Europe than you do in America. But it's a good bit of America too, North America. Okay. They tend to shed their leaves once a year, except in the rainforest where they are evergreens. They're green all year. But you think about all of those trees. We're getting up into that time of year right now where they shed their leaves in the fall. The needle leaf, this is pine, fir, and cedar. And these are your coniferous trees because they are cone bearing. Now, you know that we have a lot of pine trees here. Okay, and again, if you look at our region, it says deciduous and mixed forest. Okay, we definitely have coniferous trees. Okay, then you have your grasslands, and you'll see here yellow for us. It's a temperate grassland, but you've got other grasslands. You've got, these are flat regions dotted with a few trees, which that sounds like our prairie, right? A savanna, which is what you would see over in Africa. That's your tropical grassland. That's the savanna. You've got your steppe or your prairie. That's what we have. These are temperate grasslands. And then you have your pampas. These are also temperate grasslands, but that's what they're called in the southern hemisphere. And then you have the desert and the tundra. These are two very different regions. But these are extremes. Both of these are extremes: extreme hot, extreme cold, very little precipitation. But the plants that live here have to be specially adapted to tolerate the dry or the cold conditions. In the tundra, you've got plants that hug the ground, mosses, lichen, something to survive that cold, dry climate. And in the desert, you've got to have plants that conserve water, but also withstand the heat, like cactus, sagebrush, some shrubs that you can see throughout the landscape. Okay, so it's an interesting map too. I think that this is interesting. And as we go through each region, we're going to focus on those. Okay, we're going to focus on these regions and look at that. So what have we got next week? Well, you have a test on the first day back. So the 21st for A cohort, and Thursday the 24th for B cohort, we're going to have a map test. And then on Friday, we're going to have a test using your notes. You can only use your notes guides, so make sure, not for the map test, but for the test. And it's going to be defining geography, geographer's tools, the earth and the climate, and then soil and vegetation. So the physical world along with all the others. So make sure that you have everything completed. Make sure that you've studied. Ask me any questions, anything you don't have. You cannot take this test later if you don't have your notes with you. That's not an option. We will be doing it in class, okay? Also, as soon as we're done with this, we're going to continue with Unit 1, and we're going to finish it, and we're going to begin looking at culture, language, religion, society, population, government, economic systems. This is the human geography component of what we're looking at, and this is the kind of things that we're going to look at with each and every section. So you have it all. Let me know if you have any questions.